Garth Spencer, myself and my team, we drive innovative wireless solutions, but specifically from a field services perspective. That's essentially the perspective that I'm looking to offer to all of you today. So we're fascinated by IoT, so bringing it right back down, right? This is something we've invested in. The cover picture over there shows you one of 72,000 wireless automatic meter readers that we have and are currently installing across a rural district called Coliban in Victoria, as well as in Sydney. And we're also doing something very similar in Christchurch at the moment. So this stuff is getting real very quickly, right? But firstly, and importantly, who are Visionstream? Because you might not have heard of us, right? So on your table, there's a couple of cards, and so just taking care of business quickly. On the one side, you'll see a brief timeline of our history in New Zealand. That starts in 2009. I was employee number 6, very privileged to have been on the journey the whole way. And you can see in the bottom left-hand corner, our first significant project was the Rural Broadband Initiative Part 1. And so essentially, we connected more businesses, homes, hospitals, schools, and community centres than anyone else. From a field services perspective. And on the right-hand side of that little journeygram, you'll see the UFB 2+ communal build. So we're doing the build in 186 rural towns currently across New Zealand. So that's a little bit about us. Essentially, we're a field services company. We undertake design, construction, operation and maintenance for our partners like Chorus and others. And we currently operate the length and breadth of New Zealand with about 2,500 contractors and about 500 staff. So that's Visionstream. So on the other side of the card, there's a brief diagram of where we play. Now, I'm hoping all of you can see that at the back. Right. The part we're interested in today is essentially the wireless IoT part of the business that creates access to those end devices, those homes, and the systems that manage the data. So we've invested in a business called Vianet, which is an anagram of our parent company name called Ventia. And that's the bit we're going to focus on today, right? Our Vianet business was launched in 2015, and it's really about bringing end-to-end IoT solutions to the infrastructure services market. So that's asset infrastructure and utility services. That's why we invested in that. So we're expecting, in the sectors that we operate in, we're expecting to have millions of sensors and devices rolled out in New Zealand and Australia in the next 4 to 5 years. So it's a significant investment for us. So there's 3 things that are needed, I think, for a successful IoT model. And most of the people we talk to could only do 1 or maybe 2 of these, right? So the first thing you need, and it sounds obvious, is product. So obviously you need sensors. And these are simple, but as many of you will know, and you become perhaps challenged quite early on, finding the right sensor in the right national frequency band, in the right plastic form for the application, the end use case that you want to support. Is it waterproof? Finding it in the right technology type, and finding one that's actually in production. Those can be real challenges, right? So we've invested in that, and we've got a small part of our business that actually produces and designs sensors, which I think is important. All these use cases are subtly different. What works well in a sewage vacuum valve won't necessarily work well in a water tank. Okay, perhaps not the greatest example, but you understand where I'm coming from. The environments that these sensors are operating in are a challenge. The second area that I think we need to be nimble in is in the network. So I think Spark deploying these IoT and nationwide coverage, that's impressive. We've got an amazing national mobile network operators that are getting on board and providing this level of coverage. But I think that a lot of the use cases that we're seeing require more. They require deep local national coverage. And I'll show you some examples where higher level macro site type coverage isn't going to cut it in all use cases, right? And the third thing I think we need is services. So clearly, how we manage the data and turn that into information for our end users so that they can save money, operate more safely in the fields that they're operating in, and derive value is critical. So I think it's important that you have the ability to do all 3 if you want to play in the IoT space, or partner with someone who can provide all 3. So one of the most prevalent use cases that we're finding at the moment is meter reading. So let's have a look at some pretty real-world applications that are here. Now, this is a very standard water meter that you see. It's the most common water meter across New Zealand and Australia. It's known as an Elster V100 20 pipe water meter, if anyone's interested. But this particular meter is approximately 70% of water meters deployed look like that. And that little grey box that you see hanging on there is a Vianet IoT sensor, and we've basically designed this box to operate on a LPWAN network, because we think that this is the most suitable application or network topology that supports these. And so that's really what this Vianet business is based around now. We've got an onboard sensor that eliminates the need for an expensive reed switch. And these are all important features. When you're deploying a sensor out in the field, you need to think about battery life. You need to think about quick, simple, and safe installation. The battery inside this puppy will last 15 years, transmitting once an hour. It basically is real-time data. You deploy those things, you never need to go back to them. They're disposable, essentially. So it needs to be optimized for cost, security, and capability. And I think we're starting to get to the very real end of IoT now, where this technology is capable of being deployed on swarm technology deployments, where you can roll these things out, tens and hundreds of thousands of these, and never have to go back to them. So a little bit more about Coliban. That's a rural pastoral region in Victoria. And so across almost 17,000 square kilometers, we're deploying 72,000 of these automatic meter readers. So it's a fairly large-scale deployment for us. And what's significant here is that we're using somewhere between 100 and 130 gateways, which are your base stations, to provide your coverage. And the reason for that is that some of these sensors need to be deployed under the ground, under manholes, behind the shed. And so in many cases, we need deep localized coverage, as I was explaining earlier. And the business case drivers for this particular local government deployment are common to all of our customers, really. And they are improved health and safety outcomes. We have less people on the road, and we're putting less people in harm's way. We've got anomaly detection. So if you've got real-time usage data, there's no more guessing, right? Which leads to enhanced customer relationships, because you can extract the value and offer different products over the same set of physical infrastructure. And then finally, and this is really big, is improved CapEx decisions. So one of our clients, based in Sydney, had earmarked tens of millions of dollars for large capital works that they were going to upgrade on a water system. And once we deployed real-time a real-time IoT network that gave us real-time measurements on domestic water supply, they put off that CapEx investment by 10 plus years, because they suddenly realized they didn't have to invest tens of millions in certain parts of the infrastructure now. It was only a small part of the network they needed to upgrade to cater for peaks in demand. So I think extracting that data and putting off those capital investments is one of the big outcomes that we're seeing. And some of these pictures here, I think, will show you some of the real-world applications that we're seeing when we deploy these little grey boxes. So you can see them; they're underground, they're under pit lids, under steel lids. They're not great environments for radio engineers to be poking around, guessing how strong the signal strength is. So the LoRaWAN network technology is really robust. It's really simple. Outside, I see a bunch of boxes on display. I bought one in my bag. I didn't bother to bring it out, but you literally plug it in, turn it on, and access the data system online, and the sensors are up and operating. So we've got some really fascinating applications for these that we're using to derive value with our existing field services contracts in New Zealand at the moment. I beg your pardon. Just back to the vacuum sewer example. This is a real problem for cities like Christchurch. Right, so we've got a very flat land, often with water table issues and not great drainage. And you can see that a vacuum sewage system works where on the right-hand side of the picture you've got a large extraction plant and processing plant, and then typically outside the boundaries of most of your properties you've got a valve, and there's a small catchment pit. And so what happens is the sewage is stored in the catchment pit until it reaches a certain level, and then the valve is triggered to open, and of course the sewage is dispensed to the main plant, right? But what happens when the valve gets stuck, or the water table increases and the localized storage tank overflows? It gets pretty messy pretty quickly, right? So deploying these IoT vacuum valve sensors has radically changed the way that we're able to monitor these types of networks. So we're doing this for a large local government client in Australia and in Christchurch. So a couple of thousand of these sensors are going out right now. But in order to do this, the coverage requirements require a deep localized coverage. So we're partnering with people like Chorus, and we found some innovative ways to power these access points and these base stations over unused copper pairs on the existing telegraph or utility poles. So it's, don't just look at your national mobile network providers and RCG to carry the can on this stuff. I think there's a whole range of solutions out there to cater for the specific needs of our rural communities. And we need to work with the WISPs and with the MNOs to work out the best solutions. So there's a few other pictures you can see there of our sensors on vacuum sewerage valves, but some of the other interesting applications that we're currently using and use cases that we're supporting. We're monitoring flood level and water ingress in cable wells, exchange buildings, and data centers. We've got buried soil moisture probes in areas where our Ventia parent company are responsible for maintaining open spaces. We've got sensors really cheap sensors that monitor temperature, humidity, light level, carbon dioxide, and movement. With a self-adhesive tag, you stick them on the inside of your critical rack, and they monitor the health of the environment that supports our critical equipment that, thousands of terabits of data flow over, and Rugby World Cup, information is coursing through every day. So these critical network assets, they've been designed and operate in environments that have been based on legacy and environmental control systems. I think we need to embrace this new technology across all aspects of our business, including in the rural sector, and take advantage of the stuff which is available right now. So, look, in conclusion, one of the biggest lessons for me, and I think for us, is that we expected when we deployed these sensors that we would have events that would be generated that would either make us roll another truck or stop us rolling a truck. That's how we thought we were going to save money. Let's put a temperature sensor to determine when the temperature increases above a certain level, and we'll go out and we'll fix it. The big learning for us has been that isn't really where the money's saved. The learnings have come from the creation of the big data environment, the real data, right? So it's not about rolling a truck or attending to an event. It can be, but it's more about optimizing the routes, the cleaning routines, the bin emptying schedules. It's more about doing less based on the data that you have, optimizing your mowing cycles based on soil moisture data. And so for us, I think that was quite a big learning, right? And the other big learning really is low cost. I think if you look at this from a traditional telco perspective, you're going to struggle because, Michael, you would have struggled to answer the question around how you make a bob with this stuff because it's so different from the typical telco environment, and you can't apply a telco model to this, I believe. You've got to find a low-cost way of doing this. So for us, we can't... you can't put an army of technicians and radio engineers across this stuff. This technology is bulletproof, and we've got to adopt low-cost models in getting to it.